Hello everyone. Today I will be going to talk about how data is handling when it becomes too big for a single computer. Our topic is distributed database, a small way to store and manage bugs amounts of data across mass system any systems. This type of database helps big companies like Google, Netflix, and Amazon handle millions of users smoothly. Teamworks. We are Amit Pawar, Gayatri Pawar, and Rahul Bhorkar, and we are excited to take you through the topics in a simple and interesting way. Handling data. Distributed database for modern applications. In today's digital age, modern applications face unpredicted demands for scalability and reliability. Distributed database have engaged as a cornerstone of stability in advanced database system, offering solutions to manage ever growing data volume and users traffics. This presentation will delve into the core concepts, benefits, and challenges of distributed database, exploring their roles in enabling scalable and relevant modern applications. Introduction to data distributed database. Definition. Distributed database involves distributing data across multiple nodes, enabling horizontal scaling and improve fault tolerance. Unlike traditional and monolithic databases, distributed system can handle large workloads by leverage the combined resource of multiple machines. For example, Apache, MongoDB, and Google Scanners. These systems often different con- consistency models and architectures approach certain to derive application requirement. Each one represent a unique solution optimized for specific needs. Importance. Distributed database are critical for large scale applications that requires high availability and the ability to manage massive amount of data. They provides this they provides the scalability needs to support growing user based and increasing data volumes. Core features of distributed database. Data partitioning, splitting data into a smaller manageable pieces across multiple nodes of enhance stability. Different partitioning strategies like horizontal and vertical partitioning are used to optimize quick performance. Eventual consistency. A consistency model where data is eventually consistent across all nodes. While there may be temporary inconsistencies, the system ensures that all nodes covers to the same data states over time. Data replications, creating multiple copies of data across different nodes to ensure high availability and fault tolerance. Replications helps to maintain data av- accessi- i- accessibility when it some nodes fails.
Hi everyone, I am Rahul. I'll be talking you through some of the most crucial concepts in distributed database. starting with benefits of distributed databases. Scalability. As shown on the slide, distributed databases can handle increasing amount of data and user by adding more machines. Instead of upgrading one powerful server, we can simply add more nodes. This is called horizontal scaling. It's highly coeffective and future-proof for growing applications. Reliability, as shown on the slide. The distributed system offers high reliability because data is replicated across multiple nodes. If one server fails, other can continue working without data loss or downtime, ensuring business continuity. Performance. Performance improved because data can be accessed from the nearest server node. This reduces latency and increases the speed of transaction, which is especially important for real-time and global applications. Challenges in distributed databases. CAP theorem. The CAP theorem says that the distributed system can only guarantee two out of three things: consistency, availability, and partition tolerance. This means we can usually have to choose between having fast access to data, always being online, or keeping all copies of data perfectly in sync. We can't have all three at once. Complexity. As shown on the side, the distributed systems are harder to build and manage. You need to handle things like how data is divided, how servers talk to each other, and wait what to do if one part of the system is failed. It's much more complicated than using single database. Security. With data spread out across different server and locations, security becomes more difficult. As shown on the slide, we need to protect the data from hackers, make sure only the right people have access, and keep it safe while it's moving between servers. Consensus algorithm in distributed system. First, we have Pexas. Pexas helps server in a distributed system agree on one decision, even if some of them fail. It's reliable, but it's also quite hard to understand and implement. Next is Raft. Raft is similar to Pexas, but it is easier to use and explain. It's work by selecting one server as the leader. The leader makes decisions and shares them with the other server, called followers. If the leader goes offline, the system quickly pick up the new one. And finally, we have zookeepers. The zookeeper is a tool that helps manage coordination between servers. It helps with things like leader election, keeping setting in sync, and making sure all servers are connected properly. It uses its own consensus method called Z, which is similar to Pexas. Those algorithms and tools are important because they help the system stay in agreement even if something goes wrong. Implementing distributed databases. First, we have sharding. Sharding means splitting a large database into smaller parts called shards. Each shard holds part of the data that is stored on a different server. This makes the system faster and easier to scale. Then we have load balancing. The load balances spread incoming requests across multiple servers. This prevents any single server from being overloaded and keeping the system running smoothly. Finally, there's monitoring. The monitoring helps us keep the track system health and performance. It lets us spot problem easily, like a slow server or failing nodes. We can fix them before they affect user. Together, this system helps to build fast, reliable, and scalable distributed databases. That's all from my side. Now Gayatri will take you through the next part. Hi everyone.
So hello friends, we are going to see real world use case. So we use that particular cases into our real world. So some best example like e-commerce, social media, financial services. So in e-commerce, we handle a scalability of high traffic during its peak seasons. means the best example for it is Amazon, Flipkart. Exactly what happens, we manage the million of people throughout the database to and throughout the database like their daily transactions, shoppings, delivery, or their information like a customer care. Now, after that, we have a social media. In social media, we have a real-time messaging to user with a low latency. Low latency means it take a particularly really a mini micro time to receive your message and sending it. They have a large amount of user data. Like a best example for it is a WhatsApp. So WhatsApp have a distributed database which support billions of message every day and ensures their consistent delivery. After that, there is a financial services. Now in financial services, we ensure a global transaction consistency and data integrity. Financial institutions rely on distributed database to manage transaction across multiple regions. So we can manage it like sometime there is a apps like a phone pay, yono, where we have a deposited withdrawal and sometimes we can have a store money our money like a saving accounts, current account. Means there is a lot of financial services and it have a huge amount of database. After that, there is a future of distributed database like in edge computing, AI optimization. There are also distributed SQL. In edge computing, data we can process a data to source and which can enhance a real time capabilities where it also reduce your latency and improving your performance. After that, there is a AI optimization. Currently we use AI everywhere. So in AI there is a data distribution and query processing. Means sometimes it gives you a solution where on a present time. Means if there is any query you have, then you can get a easily solution. There is a large amount of database which can store to AI optimization, machine learning algorithms. Then it's also improves your database management. After that, distributed SQL. In distributed SQLs, this SQL offer you a balance, consistency, and performance. After that, conclusion, enabling scalability for a modern applications. Like applications means we have a distributed database which is necessarily for a modern application. It proves scalability, reliability, and their performance according to user demand and today's demands. Okay, so there is a balance between all these terms like scalability, availability, and consistency. After that, we understand user core concept and best practice organization to unlock the all future demands and distribute that particular system. Means we handle a large amount of data and a user traffic effectively. As the technology evolves, so distributed database will play a important role which can support applications and driving digital transformation. So means it is a competitive, still it manages user queries. So thank you everyone for watching our video. If you have any problem, please let us know in comments. Thanks for watching the full video.